Percent yield is a measure of how efficiently you performed your experiment. The formula for percent yield, as you can see, is actual yield divided by theoretical yield times 100. The actual yield is how many grams of your product you measured at the end of your experiment. That's what you actually obtained at the end of your experiment. That's the number of grams of isoborneol that you measured in step 94 of this experiment. So if you look at the photograph you took for the grams of isoborneol from step 94, that's your actual yield. That's the grams of the product that you actually got when you went into the lab and did the experiment. The theoretical yield is how many grams of product you could theoretically get if you did the experiment completely efficiently, with 100% efficiency, if nothing evaporated, if no speck of any reagent was ever left behind when you transferred one thing to another, if every molecule of all the reagents reacted, the maximum amount of product you could theoretically get, that's the theoretical yield. And when you calculate percent yield, that's really what takes the work, is figuring out the theoretical yield. Once you have it, you just plug it into this formula, and you have the percent yield. The times 100 here is just to make this a percent rather than a decimal. So when you see actual yield divided by theoretical yield, what that really means is you got what you got compared to what you could have gotten. And that's what the percent yield means. So if you got a 50% yield, that means you got half of what theoretically you could have gotten if you had done the experiment more efficiently. Okay, well, you have your actual yield already from your picture from step 94 of the experiment. So how do you get the theoretical yield? You start with the reagents. You look at the reagents you have, and the assumption when you calculate the theoretical yield is that all of those reagents got turned into product that you could collect. So our three reagents in this experiment were camphor, sodium borohydride, and methanol. How much product we could theoretically make is limited by the first reagent that runs out. That reagent is called the limiting reagent. And in our experiment, the first reagent that runs out is camphor. So camphor is our limiting reagent in this experiment. In order to calculate how much isoborneol we could theoretically make, we have to start with how much camphor we used. You would have measured that in step 15 of this experiment. So look at your grams of camphor from step 15 of this experiment. That's what you're going to start with when you're trying to calculate your theoretical yield. That's the theoretical amount of grams of isoborneol you could have made if you had performed the reaction with 100% efficiency. So we have grams of camphor. What we really want are grams of isoborneol. How much product could we make with that much camphor? So we want to convert grams of one thing into grams of another. Anytime you convert grams of one thing to grams of another, you have to go through moles. You have to go through moles. So let me write out a little sort of flow chart for how you do this conversion, and then we'll unpack it. You'll start with grams of camphor, but when you want to convert from grams of one thing to grams of another, you have to go through moles, so you'll convert grams of camphor into moles of camphor. Once you have moles of that thing, you can compare it to moles of the other thing using the balanced chemical equation. So once you have moles of camphor, you can convert that to moles of isoborneol. And we'll walk through each of these steps. After you have moles of isoborneol, you can convert it back into grams of isoborneol. So to calculate the theoretical yield, we have to do 1, 2, 3 conversions. So each of those arrows represents a conversion. In order to do any conversion, you need a conversion factor that relates the two units. So for example, if we want to convert grams of camphor into moles of camphor, we have to know how those two units relate. How do grams of camphor relate to moles of camphor? And when you relate moles to grams, you use the molar mass. That's the mass of 1 mole. You would look this up. If you looked this up, you would see that the molar mass of camphor is 152.23 grams. So in 1 mole of camphor, there are 152.23 grams. So much for our first conversion. To do our second conversion, we're going to need a second conversion factor. We have to know how moles of camphor relate to moles of isoborneol. We get that from the balanced chemical equation. So if you look at the equation, there is an implied 1 written in front of each of these. Each mole of camphor would turn into a mole of isoborneol. There's a 1-to-1 ratio between those. So for every 1 mole of camphor, you'll have 1 mole of isoborneol. So much for our second conversion. For our third and final conversion, we need one last conversion factor. We have to know how those two units relate. How do moles of isoborneol relate to grams of isoborneol? This is, again, the molar mass. Anytime you want to relate moles to grams, you use the molar mass. The molar mass is the mass of 1 mole. And you would look this up. If you look this up, you would see that the molar mass of isoborneol is 154.25 grams. Okay, this was the hard part, coming up with all of those conversion factors. Once you have the conversion factors, it's just a matter of plugging the numbers in. So let's start with the grams of camphor that you measured out in your experiment in step 15, and that you took a picture of. So you'll start with that number of grams of camphor. I'm just going to write X here. That will be different for every group. Every time you do a conversion, you write a multiplication sign, a fraction bar, and the units you start with go on the bottom of that fraction so that they'll cancel out. You want the units to change. Ultimately, we want grams of camphor to turn into grams of isoborneol. So we take the units we have and put them on the bottom of the fraction so that they'll cancel. We're going to fill in this first conversion with, or this first fraction, with our first conversion factor. So next to grams of camphor, we'll write 152.23. Going over the fraction bar is like going across the equal sign. So on top, we'll have 1 mole of camphor. Notice how grams of camphor cancel out, and at this point we're left with moles of camphor. But we don't want moles of camphor, we want grams of isoborneol. So we have to do another conversion. Every time you do a conversion, write a multiplication sign, a fraction bar, and the units you have on top go on the bottom of that next fraction. So in this case, that's moles of camphor. They go on the bottom because you want those units to cancel out. We're going to fill in this second fraction with our second conversion factor. So next to moles of camphor, we'll go 1. Going over the fraction bar is like going across the equal sign. So on top, we'll have 1 mole of isoborneol. Moles of camphor will cancel out, or we'll be left with moles of isoborneol, but we don't want moles of isoborneol. We want grams of isoborneol. That's the theoretical yield. So we have to do one last conversion. Every time you do a conversion, you write a multiplication sign, a fraction bar, and the units you start with on top of the fraction go on the bottom of the next fraction so that they'll cancel out. We'll fill in this third and final fraction with our third and final conversion factor. Next to moles of isoborneol, we'll go 1. Going over the fraction is like going across the equal sign. So on top, we'll have 154.25 grams of isoborneol. Moles of isoborneol cancel. We're left with grams of isoborneol. That's what we wanted. That's our theoretical yield. So we can stop doing conversions and plug this into a calculator. So depending on how many grams of camphor you started with, everyone will end up with a different number here. But the way I would encourage you to enter this into a calculator is that number, that grams of camphor you started with, times 1, enter. Divided by 152.23, enter. Times 1, enter. Divided by 1, enter. Times 154.25, enter. Divided by 1, enter. And that should give you your theoretical yield. So that is your theoretical yield. So you take that number, that theoretical yield, and you plug it in to the theoretical yield in the percent yield formula. You'll already have the actual yield plugged in. Remember, that was the grams of isoborneol that you actually ended up with when you did the experiment. And you'll multiply that by 100, and that will give you your percent yield. Remember, the meaning of percent yield is how efficiently you perform the experiment. If you had 100% yield, then you did the experiment completely perfectly. That essentially never happens. And organic chemistry is even notorious for it being very difficult to have high percent yields. So if you get a low percent yield, it's not necessarily something to be too upset about. So hopefully this video has given you some sense of of what the percent yield means, of what the formula for it is, and of how you can find the actual and theoretical yields for this experiment.